Good morning, everyone. My name is Raj Kumar Patel, and my project title is Design and Implementation of Microservice-Based Warehouse Management System. The purpose of this project is to create a scalable warehouse management solution using modern cloud-native microservice architecture. Basically, a traditional warehouse systems are often built as monolithic applications where all functionalities exist in a single system. So as the application grows, maintenance becomes difficult and system failure can impact the entire applications. So to solve these challenges, this project divides the warehouse system into independent microservice, and each service perform a specific business function and can be developed and deployed and maintained separately. Let's go to the part one executive summary, where this project focus on the design of warehouse management platform capable of managing inventory, processing customers' order, tracking shipment, and handling the user authentications. So the system consists of five major components: API gateway, authentic service, inventory service, order service, and shipment services. Each service has its own database and communicate using REST API. So the overall goal is to create a reliable, scalable, and fault-tolerant system that supports future expansions without affecting the existing service. Going to the next slide is a requirement traceability matrix. So the requirement traceability matrix ensure every project requirement is connected to a design component and testing method. For example, the inventory management requirement are implemented through the inventory service and verified using the functional testing. As of like the order processing requirements are implemented through the order service and validated through the integrated testing, as well as the user authentication requirements are implemented through the authentication service and verified using the security testing. So these metrics provide traceabilities for requirement to implementations and finally to evaluations of it, as well as the design trajectory statement, which is like every requirement approved during the host of one is mapped to a specific architecture component and corresponding validation method. This ensures full trackabilities between the project objectives, implementation decisions, and evaluation metrics to the development. Going to the system architecture design. So first is the architecture style. So instead of a large applications, the system is divided into multiple smaller service. The major architecture goals are loss coupling, service remain independent from each other, service isolations, a failure in one service does not crash the entire system, scalabilities, individual service can scale independently, maintainability, where update can be made to one service without affecting others, fault tolerance, the system continues operating even when a service experience issue. So this benefit make microservice suitable for the modern enterprise applications. I have a high level architecture diagram, which the diagram illustrates the overall architecture of the warehouse management system. The process being with the client applications, which can be a web or a mobile application. All user requests are sent to the API gateway. The API gateway act as the single entry point into the systems and route requests to the appropriate service. The service include authentication service, inventory service, order service, and shipment service. Each service maintains its own database to ensure service is independent. This design improve the scalability and reduce the dependency between the services. talking about the development implementation plan. So the project will be developed incrementally in following phases, such as the phase one, which is mostly focused on setting up the development environment, Docker container, and the database. Phase two is for the develops the authentication service. Phase 3 is for developing the inventory management functionality. Phase 4 is for implementing the order processing. Phase 5 is for developing the shipment tracking. And the phase 6 is API gateway integrations. And going to the phase 7, which is perform on the system integration and testing. And this all phase approaches minimize risks and allow testing at each stage. Coming to the next point, uh, project timelines, more like the system construction and development order. Well, so the project timelines span 12 weeks from now. The first 6 weeks focus on primarily on the development activities, and week 7 through 11 focus on testing and validations. And this schedule also more likely for the final week focus on the documentations and evaluations, but this is both enough time for the both implementations and quality assurance. I have the C4 container diagram. So the C4 container diagram provides a development level perspective of the system. The client application interact with the API gateway. The API gateway communicate with the multiple microservices, and each service is deployed independently and uses its own database. And authenticator and service use MySQL because they require structure and relational data. Order and shipment service use MongoDB because they handle flexible document based on data, and the architecture supports the independent development and the scaling of it. Coming to the component dependency diagram, so this diagram shows the communications and dependency among the services. So it start from the API gateway is the central routing component, then the order processing depend on the inventory service to verify product availability before processing the order. The order service also communicate with the shipment service to generate the shipment records. Although services interact with each other, dependency are minimized to maintain loose coupling. Going to the next, I have just explained same thing over here. Coming to the component design, the first part is API gateway. So it's basically the API gateway is one of the most important component in the architecture. It responsibilities included request routing, authentication verification, load distribution, API aggregations, centralized login. So instead of exposing all service directly to the user, the API gateway act as a secure intermediator between them. This improves both security and maintainability of it. The next point is authentication service, where the authentication service manage user access and security. Then the next part is inventory service, where the inventory service manage all the warehouse product. Going forward, it's the order service. The order service handle customers order processing. Then shipment service is handle managing deliveries and the operations for it. And going forward, I have a ER diagram. So this entity relationship diagram illustrate the database structure for the key include like user, product, order, and the shipments. User can create multiple orders. Product can be appear in multiple orders. Each order can generate shipment records. primary and foreign key maintain the data integrity and the relations of it. Going to the service interface design, the services communicate using RESTful APIs, so communication flows secured by the HTTPS protocols. JSON is used as the data exchange, and JWT is used as the authentication ensure only authorized request can access the protected services. And this interface design is support secure and reliable communication. Coming to the next part, data flow design. So the user logs in and receive a JWT token. Thereafter, the request entries through the API gateway. The order service receive the order request, and the inventory service verify the stocks. The shipment service create a shipment information, and finally, the order confirmation is returned to the user. On the yeah, it's same thing. Order warehouse processing. Then I have a UML sequence diagram. So the sequence diagram focus on the order processing workflow. It illustrates the exact order of the interaction between the system component. The user authenticate first. The authentication service generate a JWT token. The order service validate the inventory. The shipment service create the shipment record, and finally confirmation return to the user. So the diagram helps the visualization of the real-time communication between services. Coming to the data validation strategy, so the data validation occur at three levels. First, the API gateway validate incoming requests. Second, the service layer is verify the business rule, and third, the database layer, and fourth, the constraint. This multiple layer validation strategy prevent invalid and the data from entering the systems. Going to the input validation rules, so this validation rule ensure that only correct and secure data enters the systems. Product id and order id must be positive integer, quantity must be greater than 0, username must be between the 3 to 50 character, password require at least 8 digit, JWT token must be valid and not expire, and shipment date ID must be follow the UUID format. Talking about the database validation, so database validation help maintaining the data integrity. In MySQL, primary key, not null constraints, and the unique usernames and foreign keys are used. Talking about the database validation and the error handling strategy. So before processing any request, the system validate the product informations, quantity value, customer details, shipment tracking number, and the tokens. If error occurs, such as invalid login credential, missing product, insufficient inventory, invalid shipment ID, or database failure, the system responds appropriately through the rejections or validate error, exceptions, or the retire mechanism. This improve the. So coming to the point, computational method. So the computational method describe the order processing algorithm. So the system first validate the authentication, next request the data is checked, inventory ability is verified. If the stock exists, inventory is reversed, then the order shipment record is created, and at the last the order status is updated and returned to the user. Coming to the next point, the environmental and tool chain plan. So the this slide presents the development environment and the toolchain selection for the project. So Java JDK 21 is used as the primary program language because it provides the modern language feature and long-term application capability. Then the Spring Boot server as the main framework for building the microservice and REST API. It's simplified applications, configuration, and development. Maven is used for dependency management and project building. Docker is used for containerizations and allowing all services to run consistently across the different environment. MySQL is selected for authentication and inventory service because this service manages structures and relational data. MongoDB is selected for order and shipment service because the benefits from flexible document based on the storage. Postman is used for API testings. GitHub provide the version control and collaboration capabilities. Visual Studio Code servers and development environment. Together, this create a complete and reproducible software development ecosystem. Coming to the development architecture, so um, a service run inside the Docker contains the development environment consists of the API gateway container, authentication service, then inventory service container, then order service container, shipment service container, and MySQL container, and the that MongoDB container. So Docker network allows secure communication between containers, and containerization provide several advantages. First, the consistency development across the development and testing environment. Second, easier scalabilities because the individual container can be replicated. Third, improve the isolation because each service runs independently. This development architecture supports overall microservice design uh, as well as the software. Then coming to the Docker environment and the reproducibility. So an important requirement of any software project is reproducibility. So another developer should be able to build and run the system without additional instructions. So he just basically need to he or she must need to set up the process including installing of the Java, JDK, Maven, Docker desktops, as well as the MySQL, MongoDB, the database, and cloning the GitHub repositories and running Docker compositions and building service using Maven. So once completed, all microservices should start successfully and communicate through the Docker network. This ensures the system can be reproduced, tested, and developer consistencies. Coming to the API container planning, so API container define how client communicate with the services. And for example, the authentication service provide endpoint for the registrations and login. The inventory service provide endpoint for the product creation, update, retrievals, and deletions. The order service provide endpoints for the order creation, retrievals. The shipment service manage the shipment creation and tracking. By clearly defining the API constraints, this service communicate remains standardized and predictable. The next point is external dependency. So as I say, I have used the Spring Boot, Spring Security, JSON, the JWT, the JSON Web Token, Spring Cloud, JPA simplifying, MongoDB, Swagger OpenAI, which is automatically generating the API document, and the using established industrial standard libraries improve the maintainabilities and reduce the development time. So the external dependency provide the foundational infrastructure required for the application development, security, database management, API documentation, testing, containerizations, and development. So using the industrial and standard framework and tool improve the scalability and reproducibility of the software. Coming to the next point, testing and evolution plan. So multiple testing level will be used to validate the system quality. First is the unit testing, verify uh, individuals, components, and method. Then integrations testing, verify the communication between the services. Systems testing, validate the complete business workflow. Performance testings, evaluates the system responsives and underloads. Then it will be the fault tolerance testing, which is verify the system behavior during the failures. Then the each testings level like target a different aspect of a quality to ensure the final system is reliable as well as stable. Next slide is for I got covered all this. Then this is cover the evidence collection strategies. So testing result must be supported by the measurable evidence. Evidence will be collected from multiple sources. This include the JUnit test reports, Postman screenshot, JMatter performance report, Docker logs, database transactions log, GitHub component history, and integration testing reports. All evidence will be sorted in the project repositories and including the final submission. This evidence also demonstrate that the project object have been achieved at all, and the successful criteria mapping where each slide defines how project success will be measured, like the authentication success rate must be exceed 95, like less or greater than 95%, such as same for the inventory, order processing, shipment tracking, and shipment uptime. Talking about the security control must prevent the unauthorized access, and these measures criteria provide objectives, evidence that the system meet the project requirement. Baseline comparison strategy. So it is to justify the microservice approach. The project compares against a traditional and monolithic architectures. So in a monolithic architecture, whole functionality exists in a single application, which development require updating the entire system and failure can be impact the entire applications. Talking about the microservice architecture, so services scale independently, development occur per service, and fault isolation is significantly improved and maintenance is easier. So this comparison demonstrate why the microservices are better suitable for the modern warehouse management systems. Coming to the risk and mitigations, which is every software project involve risks, but the major risk identification include the Docker configuration issue, the service communication failures, database integration problem, and security vulnerabilities and scope explanations. Coming to the next point, design reviewing, discussion, and supervised feedback. So during the design review, several improvement opportunity were identified, and also I have focused on the feedback which previously I have got. So service dependency documentation, communication flow clarity, performance testing coverage, authentication validation, trackability improves, and to address this feedback, several enhancements were made, whereas UML sequence diagram was added, component dependency diagram was added, testing matrix was expanded, API container were improved, and these updates strengthened the overall design package of it. I have also added some of the reference which mostly just I have used or based on it, and I have also attached the AI log as the academic integrity statement. And in conclude, like this project present a complete design for a microservice-based warehousement systems. And as I say, this architecture also supports the scalability, reliability, fault tolerance, maintainability, and security. And this implementation plan testing strategies and the development environment, evolution framing, and provide a clear roadmap of a development. So basically, this project is now ready to move from the design phase into the implementations and testing. Thank you for your time. And if any question regarding the architecture, implementations, or approach or testing strategy, you can respond me back. Thank you.